In this lesson, we're going to look at tangency, and we're going to look at two techniques to prove a line is a tangent to a circle. So the first example here says show that the line x plus y equals 4 is a tangent to the circle with equation and so on. So the first thing that should strike you, the x plus y equals 4 is not in the right format. We need it to be y equals or x equals. So rearrange it. Take the x over the other side to get y equals. It doesn't matter if you did x equals 4 minus y and rearrange that way. That would be absolutely fine and you would solve it the same. But I'm going to choose y equals 4 minus x, and then I'm going to substitute that into the circle. So every time I see a y, look here, I'm going to put 4 minus x, and here I'm going to put 4 minus x. And that's going to end up looking like this. So as long as my algebra is okay, and I can multiply brackets out accurately, and I can collect like terms accurately, this is an okay question to do. So you can write 4 minus x times 4 minus x, like we did in the last lesson, or if you're quite good at it, you can do 4 times 4 is 16, take away 4x, take away another 4x, which will be negative 8x, and then a plus x squared, so that's what that's going to come to, 16 minus 8x plus x squared. We've now got this plus 6x, and then we've got 8 from the 2 times 4, and take away 2x. Take away 22 equals 0. So let's collect the terms up together. There's an x squared and an x squared there, so it's going to give me 2x squared. Then we'll highlight the x's, so I've got a take away 2x, a 6x, and a take away 8x. So we've really got 6 take away 2, which is 4, take away 8, so that's going to be take away 4x. And then we're left with a 16 plus 8, which is 24, take away 2, that's going to be a plus 2. So factorise at this point again. Take out a common factor of 2, so x squared minus 2x plus 1. And then factorise the brackets, so we're going to have a 1 and a 1 at the end, and there needs to be a subtract and a subtract. Now, x equals 1 or 1, so this proves there only is one point of contact because the roots are the same. So since the solutions are equal, there's only one point of contact, therefore the line is a tangent to the circle. Now to complete the point of contact, you can substitute the 1 back in up here to get your y value. So if x is 1, then y must be 3, and so on. Now the other solution, or the other way to do this is on the next slide here. So we carry on exactly the same up to here. Do exactly the same things. I've rearranged to y equals minus 4 minus x. I've substituted it in. I've got down to here, down to this point here, but then I go into the discriminant. So I can use the discriminant to find one point of contact. It's very similar to just using the discriminant for your quadratics, finding if it crosses the x-axis once, twice, or not at all. So a is 2, b is the coefficient of x, which is minus 4, and c is 2. Now, the discriminant is equal to b squared minus 4ac, and if it comes to 0, then there's one point of contact. So b squared is going to be negative 4 squared minus 4 times 2 times 2. So this is going to come to 16 take away 16, which is 0. So a wee statement to finish it off. Since b squared minus 4ac equals 0, the line is a tangent to the circle. Just a wee point on this, if the point of contact is required, then the first method is more efficient. If you proved it was a tangent here, then you'd have to go back to this point and factorise to find the point of contact. So it's not a good method if you're looking to find a point of contact, but some people find it easier to do the discriminant here to prove a tangency.